Summer Physics 1-2, we're going to continue our study of forces, and this is the Day 7 lesson on computing force. So what is mass? Mass is the amount of matter, just stuff that an object has in it. The amount of matter your body has in it does not change whether you're on Earth or in outer space. So your mass never changes anywhere in the universe. So the birthday girl has a mass of 20 kilograms, whether she is on Earth or floating in outer space. In other words, the number of atoms, molecules, all the substance in her body doesn't change whether she's on Earth or in outer space, and therefore she has the same amount of mass. So what is the units of measure of mass? The basic unit of measure mass is the gram. One large paper clip has a mass of 1 gram. Now, usually we use a measure of 1,000 grams in physics, and that's called a kilogram. So the abbreviations for mass are small m for mass, small g for gram, and small kg for kilogram. Your mass never changes anywhere in the universe. So what is a formula for force? So force equals mass times acceleration. The formula is F equals ma, where F is force, m is the mass measured in kilograms, and acceleration is measured in meters per second per second. What is the unit of measure for force? So what is a newton? A newton is the metric unit of measurement of force. So 1 newton equals the unit for mass, which is a kilogram, times the unit for acceleration, that's a meter per second squared. So it's a kilogram meter per second squared. So a newton is the amount of force that it takes to accelerate 1 kilogram mass at 1 meter per second per second. Now, a key to this formula is that if you simply want an object that's moving to keep going, to maintain a constant velocity, it does not require any force. Up until Isaac Newton came up with this formula, they thought that if you wanted to keep an object going, you would have to keep putting force on it, but you don't. Once an object is moving, it will never stop unless a force acts upon it. So why does it seem like everything on Earth that we would push would eventually come to a stop? If you roll a ball, it eventually comes to a stop. If you push a box across the floor, it eventually comes to a stop. And that's because there is force acting against it. That's friction force. But if you're in outer space and you just give the slightest touch to a ball and there's no planets, no stars around, it will just keep moving and moving and moving forever. So you don't need force to keep an object moving. You just need force to accelerate an object to get it moving, and then it will continue to move on its own. So how much force is required to accelerate a 4 kilogram cart at 5 meters per second per second? So the first thing you have to ask is, what is the question asking for? That's step 1 of breakdown format. It's asking for force. So you go to your gold sheet, and force is abbreviated by a capital F, so it's F equals question mark. Next, the step 2 is to identify what the question gives you to work with. So the next thing you see is 4 kg. So you use your gold sheet to determine what the variables kg and ms over s measure. So kg, if you look at your gold sheet, you'll find it, and it measures mass. So m equals 4 kg, mass equals 4 kilograms. Similarly for the next one, acceleration, 5m over s, go to your gold sheet if you don't know what m over s is a measure of, and you'll see that it measures acceleration. So acceleration equals 5 meters per second per second. Now you have all of your variables. Okay, you have f, m, a, so you go to your gold sheet and look for a formula with f, m, and a in it. And you see that it's right there, it's f equals ma. So now you plug in the numbers. That's step 3 is getting the formula. Now plug in the numbers as step 4. So force equals 4 kilograms times 5 meters per second per second. So that equals your final answer. There it is right there. And so your final answer is going to be 20 newtons. So a newton is a kilogram meter per second, so that's 20 newtons. Okay, here's another problem. Anna pushes a 3 kilogram box with 17 newtons of force. A 5 newton friction force opposes the motion. At what rate does the box accelerate? So first you must find the net force. That's something we did in the last lesson. So the net force equals the force that Anna's pushing with minus the force that's opposing her, which is the friction of the box sliding along the floor. So 17 minus 5 is 12 newtons. So that's the number you're going to work with. It's as though she were pushing with 12 newtons of force and there was no friction force opposing her. So we work with the number 12 newtons. Okay, so now use F net to solve for the acceleration. So what's the question asking for? It's asking for acceleration, A equals question mark. Then it gives you the net force. We figured that out, the net force, 12 newtons. And it gives you the mass, which is 3 kilograms. So now you find the formula of F equals ma. You won't find F net. It's just going to be F equals ma. There it is. But we're not solving for force in this case. We're solving for acceleration. So you have to do one basic algebra step. You have to divide both sides by m, and when you do that, the m's on the right cancel out, and so what you end up with is acceleration. So that formula is now solved for acceleration, which is what we're looking for. So acceleration equals net force over mass. Now you plug in your numbers. The net force is 12 newtons, the mass is 3 kilograms, and you divide, and acceleration is measured in meters per second, so you get 4 meters per second right there. And that takes care of this lesson on calculations of force.